the story that motivated us to study and tackle the problem that I'm presenting today. We were collaborating with a group of researchers in biomedical engineering of our university, and they were working with these kind of videos for two image modalities, phase contrast and fluorescence, and they were interested in coming up with accurate boundary of cells in each of the frames of these videos. They gave their data to us. Previously, the way that they were doing this problem, they were sitting and they were trying to draw the actual boundary, like domain experts were in charge of doing that. So they gave their data to us with this hope that we can come up with a more automatic way to solve their segmentation problem. And we started with the state-of-the-art level set algorithms, which are freely available and widely used methods to automate finding accurate boundary of different structures in biomedical images and videos. And the way that it's working, the algorithm starts with an initial contour, and then the level set methods evolve that curve to the final boundary. After doing literature survey, we found a tool called Crowdsourced, which is published in ICIP 2010. The way that it's working, it can support 6 different level set methods, and it can pair them with different initial contours. The things that they're supporting is rectangle and circle, and also hand-drawn boundary. And we started trying it with our data. We started with phase contrast, we initialized it, we got the final result, and then we moved to fluorescence images, we did the same thing. And what we found was the way that level set methods were working on our data was not appropriate at all, so we didn't get accurate boundaries. So we felt that, all right, we have some challenges. Some of those challenges are related to the nature of the images that we are dealing with. For example, in our phase contrast and fluorescent images, there was a lot of noise in the background, or sometimes it was really difficult to detect the foreground from background. Ambiguous boundary was in the images. Also, there was variation between shape and intensity. So what we were hoping to provide our collaborators with was the accurate boundary, or a more automatic way to make their lives a little bit easier. So we started looking into this problem that why level set methods paired with some initial contours are not doing a wonderful job for their images. Is that a pairing between level set method and initial contour that can work well? Or what's wrong with level set methods? So we started doing a comprehensive study of the impact of initial contours in level set algorithms. And also we did a comprehensive study of comparing different level set methods. And the most important contribution of this presentation is the analysis of using crowdsourcing initial contours. And we got really surprised because we felt that initial contours that were coming from internet workers were the most promising ones for level set methods. For our data, we used a homegrown publicly available data set that had 2 different types of image modalities, phase contrast and fluorescence. Study number 1, we started to see whether different initial contours can impact the performance of level set algorithms. So based on the suggestion of the literature, we used 4 different basic shapes: rectangle, ellipse, circle, and triangle, and we used it to initialize the level set algorithm. We used them in 3 different sizes: big, small, average. And we paired them each time, one shape with one size with one of these 6 level set algorithms: geodesic, Shanwei's, Langton, Lishi, and Gurari. For comparison, we used the traditional way of comparison with gold standard, and we used the Jaccard index. So I'm going to first explain the way that we're representing the result for one level set algorithm, then we're going to see the overall result together. So for each level set algorithm, I'm going to show one image, which on the left you can see the phase contrast result, or result for phase contrast images, on the right for fluorescence images. Y-axis is the Jaccard index, and each bar is representing one initial contour. The first 4 colors is for rectangle, ellipse, circle, and triangle. And the reason why you see 3 for each of them is because we used 3 different sizes for each initial basic shape. All right. So this is the result for all 6 different level set algorithms that we have. And if you look at, for example, just phase contrast images, you can see that initial shapes didn't do a good job for level set algorithms. So for phase contrast images, we didn't get a good result when we paired level set methods with basic shapes. However, for fluorescence images, the result was better. And for example, in one case, which was Bernard, we got wonderful result when we paired Bernard level set algorithm with basic shapes. So what we got, all right, now we can get back to our collaborators and tell them for fluorescence images, you don't need to do any effort anymore. You can just use Bernard level set method and pair it with one of these basic shapes and get great results. However, for phase contrast images, we still don't have a way. That's why we kept searching. So in our second study, we was using the same 6 level set algorithms. In this time, we paired the level set algorithms with the best possible state, which is the gold standard segmentation mask. The reason why we did that, we wanted to see, is level set method a great application, a great framework for our specific application, or we're just using a wonderful tool but for a wrong application. So for example, in this case, if we start with gold standard initial contour, a perfect tool shouldn't move the initial contour, shouldn't evolve it to another place because it's already on the actual contour. However, if we're using an imperfect tool, the contour is going to evolve to different sides and it's going to get far from the actual boundary. After using this, you have to look at the purple bar, which is showing the gold standard result. So as you can see, for phase contrast images, for example, for 2 cases, Langton and Shi, the result is great, and it's something close to highest Jaggard index. For fluorescence images also, it didn't get anything worse. Like, for example, as you can see, in Shi and Bernard, for fluorescent, the result is pretty great. And for phase contrast, Langton and Shi did a wonderful job. So we already had a tool for fluorescent images. For phase contrast images, now we found that Langton and Shi are going to do a great job. However, we still don't have the way to initialize it correctly. And that's why we hypothesized that if we use an initial contour that more closely hugs the actual boundary of the object, probably the results of the level set method are going to be improved. And that's why we used Amazon Mechanical Turk, which is a crowdsourcing platform. You can sign up in this website both as a requester and as a worker. We did it as a requester and we posted our jobs, which was we connected labeling and online annotation tool to Mechanical Turk. And each time we were posting the image of one cell and we were asking workers to come to our system. And after reviewing instruction, which contains some good label objects as example and bad object labels and all these things, then they were supposed to see the part B of this image, which was the actual task. They were supposed to draw the boundary of the object and submit their task. So we were giving them 2 cents for compensation upon completion of the task. 32 hours and 35 minutes was the time that we spent to gather 5 different annotations per image. And the reason why we gathered 5, because we fused them for quality control. 40 unique workers completed all of our drawing task, which was 271 image 5 times. And the average time for each worker was 46 seconds for drawing the cells. And now you have to look at the blue bar of each chart. As you can see, for phase contrast images, the result of the crowdsourced initial contour is wonderful. It's even close to the gold standard. So this is for phase contrast, and also for fluorescence images, it's doing a wonderful job. Again, it's not getting anything, it's not making anything worse. So we already had 2 for fluorescence. For phase contrast, finally we have something to get back to our collaborators. We know that Langton and Shi paired with crowdsourced initial contour can do a wonderful job. Besides that, we did another additional study and we gathered all the results. These 5 results are coming from internet workers, and we got so surprised that they did a wonderful job in annotating the cells. And the work that they did was even comparable with our gold standard, which was coming from domain experts, our collaborators, PhD students. And because of that, if you're interested, you can come to us in the demo session. We have the same cell setup in the crowdsourcing platform. If you like to experience this, you can come and we're going to ask you to draw a boundary of that for us, and we're going to evaluate it, and we're going to give the best annotator, the winner, $20 or like And all right, I'm going to wrap up. So our problem was we didn't have a wonderful tool to automate finding boundary of cells in our data set. We find the tool called Crowdsourced. However, the person should sit and draw the initial contour and wait for a couple of seconds or minutes until the first or initial contour evolves to the final boundary. And sometimes, like here, the result is really bad, so the person should redo the whole process, initialize it with another initial contour. We, instead of using this procedure, we developed and wrote a system that with just one click, you can get a bunch of images from one folder, and you can run all different pairing of initial contours and level set algorithms on that, and got all the results with just one click. And we're giving all the code in this website. Also, if you're interested to try crowdsourcing, and if you're curious to see how crowdsourcing is going to do on your data, we now have the expertise to try crowdsourcing on different kind of image modalities. So I'm going to be more than happy, if you like, you can come and talk to us, and we're going to be more than happy to try crowdsourcing on your data. Also, if you are interested to try it yourself, there is a tutorial about, it's a tutorial about crowdsourcing and some instructions there. It's not going to take more than a day. It's pretty easy to set up based on the instructions that we're giving in our website. And you can just try it on your data. Finally, I want to thank NSF Grant, and I'm really happy to take any questions.